Hmm. Hello students, today we are going to discuss response of overdamped second order system for unit step input. Now we know that C of s divided by R of s equal to omega n square plus s square plus 2 eta omega ns plus omega n square. Now, for a overdamped system, the eta value will be greater than 1, where eta is the damping ratio. We know that eta is the damping ratio. Now, we can factorize s square plus 2 eta omega ns plus omega n square. Now, if we factorize, how we can factorize? We can tell a is equal to 1, that is coefficient of s square, b is equal to 2 eta omega n, the coefficient of s, and c equal to coefficient, that is omega n square. Now, the value of s will be equal to, the value of s will be equal to minus b plus or minus root of b square minus 4ac divided by 2 into a. Now we can substitute the value of a, b, c in that equation. What do you get? Minus b plus or minus root of b square minus 4ac by 2a. In that you can substitute. Now s equal to minus 2 eta omega n plus or minus root of b square 4 eta square omega n square minus 4 into a into c divided by 2. That is equal to minus 2 eta omega n plus or minus 2 into root of, you can take this 4 common and you can bring it to the outside the square root, that is eta square omega n square minus omega n square, the whole divided by 2. We can take the 2 common from both numerator and denominator and can cancel the 2 and write down the remaining. Now this is equal to minus 2 eta omega n plus or minus, that is, you can, if you remove this 2 from both numerator and denominator, we have minus eta omega n plus or minus eta square omega n square minus omega n square, which is equal to minus eta omega n plus or minus omega n square, if you take it outside, omega n in the root of eta square minus 1. Now what is this? Now we have two roots here, minus eta omega n plus omega n into root of eta square minus 1, and the other root is minus eta omega n minus omega n into root of eta square minus 1. Now we can take this value, that is minus 1, as the root value as s1. This value as, you can take it as s2. This is S1 and S2. So now we can write the equation. Now how we can write the equation? C of s divided by R of s, we know that it is equal to omega n square divided by s square plus 2 eta omega ns plus omega n square is equal to omega n square the whole divided by first root s plus s1 into s plus s2. You can write it as second root. Now this is the equation. Now we want to solve this equation. How we can solve this equation? Now we can use partial fractions. Before that, you can give the input to the step, that is unit step is the input. Now R of t is equal to 1, the power unit step. So what will be R of s? R of s equal to 1 by s. Now C of s divided by 1 by s equal to omega n square divided by s plus s1 into s plus s2. Now C of s equal to omega n square divided by s into s plus s1 into s plus s2. Now we can apply partial fractions. So C of s equal to a by s plus b by s plus s1 plus c divided by s plus s2. Now how we can do? Omega n square divided by s into s plus s1 into s plus s2. Now this is equal to a by s. Now we can take this LCM, s into s plus s1 into s plus s2. Now a into s plus s1 into s plus s2 plus b into s into s plus s2 plus c into s plus s1 into s. Now first, in order to get the value of a, we can apply. Now equate the numerator omega n square into a into s plus s1 into s plus s2 plus b into s plus s2 plus c s into s plus s1. Put s equal to 0. Put s equal to 0. We get all the terms equal to 0. And only the value of a we get. That is a into s1, s2 will be equal to omega n square. Now a is equal to omega n square divided by s1, s2. Okay. Now we have to substitute the value of s1 and s2 to get the correct value of a. A is equal to omega n square divided by eta omega n minus omega n root of omega n square minus 1 into eta omega n plus omega n into root of eta square minus 1. Now this is of the form a plus b into a minus b. Here you can write it as eta square omega n square minus omega n square into eta square minus 1. This is equal to omega n square by omega n square, which is equal to 1. Now b. How to find b? We can equate the s terms or s square terms. Now see this. Now we can equate the s terms. Now we can equate the s terms. Now while equating this s terms and s square terms, we get the value of b and c as b is equal to omega n square by minus s1 into minus s1 plus s2, and c value we will get it as omega n square by minus s2 into minus s2 plus s1. Like this we get. Now we can substitute and find out the value of the remaining. That is b is equal to minus omega n square. You can bring this omega, that is s1 into minus eta omega n plus omega n into root of eta square minus 1 plus eta omega n into root of eta square minus 1, which is equal to minus omega n square to omega n into root of eta square minus 1 into s1 is equal to minus omega n by 2 root of eta square minus 1 into 1 by s1. Now c is equal to omega n square by 2 omega n into eta square minus 1 into s2. We get the similar answer. Now we can substitute for c of t. Now c of t is equal to inverse Laplace transform of 1 by s minus omega n into root of divided by 2 into root of eta square minus 1 by s1 into 1 by s plus s1 plus omega divided by 2 into root of eta square minus 1 by s2 1 by s plus s2. Now c of t will be equal to 1 minus omega n by 2 root of eta square minus 1 by s1 e raised to minus s1 t plus omega n by 2 root of eta square minus 1 by s2 e raised to minus s2 t. Now again c of t is equal to 1 minus omega n by 2 root of eta square minus 1 e raised to minus s1 t by s1 minus e raised to minus s2 t divided by s2. Now where s1 equal to eta omega n minus omega n root of eta square minus 1 and s2 is equal to eta omega n plus omega n root of eta square minus 1.